Good afternoon, grade 9s. Today we're going to look at linear equations and inequalities, lesson 6.2. And in this lesson, we're going to take a look at solving some equations using some balance strategies to help you see how to do or how to address split variables. That's where you have variables on both sides of an equation, on the equal sign. And we're also going to take a look at how to get rid of fractions in equations so you don't have to worry about working with fractions. So let's get started. Split variable problems. In last session, we used building and reversing equations to help you to be able to solve problems. And this works just fine, except that sometimes we have a different situation. And if it's a different situation, you take a look down here. This is what we call a split variable. We have variables split off on both sides. Now, if I want to show this on the pan balance, what I have to do is I've got two x's here, so I could put two x's down. There's my two x's. And then four little ones there. This is what we did in grade 7 when we first started out. And of course 3x plus 2, there's your 3x's and there's plus 2. Now if I want to show what this symbolic representation is, there you have it. 2x plus 4 is equal to 3x plus 2. Now to solve this question, the first thing we need to do is we're going to take and get the x's on the same side. That means one side of this equation I've got to remove the x's from. So I decided what I was going to do is I was going to take two x's from the left side. Now when you're doing this, I caution you, it's a lot easier to do if you always try to leave the x positive, because that'll cause problems a little bit later. So try to make sure that the x is positive. Doesn't matter which side it's on, just make sure that you keep it positive. So that's what I've done here. I've taken away two x's from the left and two x's from the right. And this is what it looks like symbolically. 2x, take away 2x, plus the 4 we still have here, is equal to 3x's, take away 2 of them, plus the 2 little tiny right there. So when I'm done, this is what it looks like when you draw it. Left-hand side, my x's are now gone, but I have my 4 little ones there. Right-hand side, I've got my x, and I've got 2. So I've now got 0 because the 2x's here are now gone, plus the 4 is equal to x plus 2. So if I simplify it, it means 4 is equal to x plus 2. Now the next step is I've got to get rid of these 2 here so I can have the variable isolated by itself. So to do that, I'm going to take 2 from each side. By removing 2 from here and 2 from there, what ends up happening is I end up with the x by itself, and that was our goal, to find out what the value of x is. So symbolically, I have 4, I'm taking away 2. Over here I had x plus 2, but I'm going to take away 2. And that leaves me with x on the right, 2 on the left. So the value of x is 2. Now, we have to work with positives and negatives and all that kind of stuff. So let's go back to our algebra tiles. And let's try another problem using algebra tiles. So we have a problem, 3x minus 4 is equal to 2x plus 6. So I need to model this equation. Now I've gotten rid of the pan balance, but I've still got this little bar here, and that represents my equal sign. So here's my left side equals right side. So on the left-hand side, I've got to have 3x's, and I have to have negative 4, which is very easily done like we've done before. On the right side, I've got 2x, plus I've got 6. Now I told you to try to make sure that we keep everything positive. So I want to take away 2 x's from each side so that this x will stay positive. So I'm going to remove 2 x's from each side. That means that what's left over on the right-hand side is 1x left over, sorry, left-hand side, and the 4 negatives. On the right-hand side, I just have the 6. They're laying there, the 6 ones. So when you clean it all up, you end up getting this. I've got x, take away 4, is equal to 6. So now I've got to get rid of these here. Now to get rid of these here, remember we talked about not using, trying to put zeros in. We're going to go with add the opposite kind of thing. So I need to add the opposite of negative 4. Well, to add the opposite of negative 4, I'm going to put a positive 4 beside each one. There's my positive 4. Now the positive 4 and the negative 4 become 0, but whatever I do on the left-hand side, I've got to do on the right. So over here I had 6, now add 4 more, and I now have 10. Cleaning it all up, I now have x is equal to 10. Right? Okay, moving on to the next equation. Let's do the same question we just did, but we're going to do it algebraically. All right. Now, if you remember what we did the first time, we took a look at this here 3x minus 4 and equals to 2x plus 6. I need to get rid of the 2x. To do that, I subtracted 2x from both sides. So there's my subtraction of 2x from both sides. So I've got 3x take away 2x and 2x take away 2x. Now the 2x subtract 2x gives me 0, and the positive 6 sticks around. And if I have 3x and I take away 2, that means I have 1x left over. Right? So that means now that I've got to clean it up a little bit. So I'm going to take and get rid of the 1 and have x, get rid of the 0. So now I've got x minus 4 is equal to 6. Now to get rid of the 4, I've got to add a positive 4 to it. Whatever I do to one side, I have to do to the other. So now I've got x minus 4 plus 4, and I've got 6 plus 4. Now, negative 4 and positive 4 give you 0, and 6 and 4 is 10, which means I now have x equals 10. So this is algebraically, and the other method was using the other stuff, the tiles and stuff. Okay, so what I want to do now is we're going to get you involved. I want you to model negative 2x minus 6 is equal to 4 plus 3x on this, this space right here using the equal sign. I wanted to say pan balance, but it's not really. So I want you to model this, okay? So pause the recording and model out this equation here. Okay, so negative 2x, that means I have to have negative 2x's. Minus 6 means I need negative 6. 4 means I have to have 4 positives. And 3x means I've got to have 3 positives. All right? Now, I want you to think about how do we get rid of some of this stuff here. Now, remember, I want to keep everything positive. So I don't want to mess with these because they're already positive. So I'm going to go over here and I'm going to try to get rid of the stuff on the left-hand side. Now this is a negative x. There's 2 of them. So if I add 2x to each side, then what will end up happening is I can then get rid of this. But whatever I do to the left side, I've got to do to the right. So I'd like you to continue this problem using that information I've just given you. I want you to draw the next set of tiles adding 2x to each side. Okay, so adding 2x to each side, I've now got negative 2x and positive 2x. This becomes 0. So now I don't have split variables anymore. Now all the variables are going to be over here. Now remember, I added 2x here, positive, so I add 2x here. So now I've got positive 5x on the right-hand side. Now the negative 6 we haven't done anything about, and of course the negative 4 we haven't done anything about. So when we simplify this, this is what we get. Okay, so pause the recording and copy out these tiles here, and then we're going to go to the next page, and I want you to draw the tiles that gets rid of the positive 4 here, so that we don't have to worry about having the variables on one side and with an actual positive here. We want to get the variables totally isolated. So pause the recording and do that. Okay, so in order to make this work, I've got to add negative 4 to each side to make the positive 4 here go away. So there's my negative 4 and a positive 4. I had positive 4. I've got to get rid of it. I put a negative 4 with it. Now if I do this to the left-hand side, this is what I had on the right. If I do this to the right-hand side, I've got to do it on the left side also. So here's the 6 I had, add negative 4. Now the negative and positive 4 here becomes 0, but of course this hasn't been affected at all. Now, when I simplify this, these are no longer going to be there. I'm just going to have the 5x's there. And on the right-hand side over here, I still have my 10. So what I want you to do now is I want you to pause the recording, and I want you to draw these grouped. So pause the recording and draw them grouped. All right, now to make it grouped, you have to take all of these negative 10, and I'm going to split them up into 1, 2, 3, 4, 5 groups. So here's what I start with. I've got one of them here, which is positive x on the right-hand side, matches up with 2 on the left, which are negative. Again, another row there. And as we go down, we'll see that each one of these x's matches up to a negative 2. So what that means is my solution is right there. I've got x is equal to negative 2. Good. Now, algebraically, I'm going to get you started on this so we can get rid of the variables on the one side, but then I want you to finish it off. So taking a look at this, the first thing I want to do is get rid of the x terms. And now we start with the x terms. So I take a look at the 3x. If I subtract 3x from both sides, I'll have negative 5x over here, which is a pain. Want to keep things positive. So this negative 2x has got to go away. Now to make a negative 2x go away, we combine it with a positive 2x. But whatever we do to the left-hand side, we have to do to the right. So starting here, I'd like you to finish off this problem. So pause the recording and do that now. Okay. Negative 2x and positive 2x give me 0. A 0 and a negative 6. This is where a mistake would happen. A lot of people just draw a 6 there, but that's not a 6. Cover the 0 up for a second, and you'll see that that's actually a negative 6. So don't drop the negative there. Now, I've got to get rid of the 4. To get rid of the 4, I have to subtract 4. So I've got negative 6 on the left, subtract 4, and on the right-hand side, I have 4 take away 4 plus the 5x that's still there. 4 and negative 4 becomes 0. And negative 4 and negative 6 become negative 10. Clean it up. I'm now at 5x is equal to negative 10. Now, doing my grouping, I've got to get this separated out into 5 groups. So to do that, I'm multiplying by 5, so I have to divide by 5, both sides. 5 divided by 5 is 1x. 10 divided by 5 is 2, and this 5 is positive, so negative divided by positive is a negative. There we end up with x is equal to negative 2. If I'm going to mark this, it would be what you did, what you got, what you did, what you got, what you did, what you got. Remember I told you before that the 1x's and the 0 statements, these ones are all optional. I'm not going to be doing marks for it. If this was an assignment, obviously you get a mark for that too. If it was a quiz or test, you wouldn't. So this question would be worth approximately 1, 2, 3, 4, 5, about 6 or 7 marks depending on what kind of a evaluation it was. Okay, now it's time for you to do one. All right, I want you to take and model this, and then we'll do this together. So I've got 2x plus 3, so I have to have 2 x's, and I have positive 3 there. Here I have negative 5, and on the bottom of it I have negative 2x. So there you go. You've got your assignment, your question there. I want you to solve this equation and go all the way down as far as you can go until you get the final answer. So pause the recording and complete the whole thing. Okay, well, I need to get rid of the, deal with the x's first. So this one here is a problem. I've got negative 2x here, and I want to keep everything positive, so I'm going to add 2x to both sides. So there is what I'm going to do here. I'm going to add 2x's right there to that side, and over here, I'm going to add 2x's here. Now these 2x's and the negative 2x's, these become 0, so they become removed. They're going to go away and not be a problem for us. Going to the next page. Now, if I simplify everything, this is what I end up with. My 2x's and my negative 2x's have left, and I've got 1, 2, 3, 4x plus 3 is equal to negative 5. So now I can get rid of these 3. To do that, I've got to add a negative 3 to it. So here we go. I keep the 4x's. Here's my positive 3. I put a negative 3 with it, and this side here will go away. On the right-hand side, I had a negative 5, but I'm going to add negative 3 because whatever I do to the left side, I have to do to the right. Simplifying it out, this is what we end up with. 5x on the left, these are now gone, leaving us with negative 8 there. Now grouping the tiles. Every one of these has to match up with an equal amount of those. So we end up with x on the left and negative 2. So we end up with an answer of x equals negative 2. And I want you to circle this for me so you tell me that you know that one of these is actually that. So this here number here, or sorry, this little statement that x is equal to negative 2 should be circled. Okay? All right, moving on. Algebraically, I'm going to get you started with this because I want you to work the same way. So we're going to deal with the negative 2x first. So I'm going to add 2x to both sides. So now I want you to pause the recording and I want you to finish this off. Okay, we're going to follow the exact same steps we used when we were working with the tiles earlier. 2x and 2x is going to be 4x. Negative 2x and positive 2x gives me 0. Clean it up, get rid of the 0. We now have 4x plus 3 is equal to negative 5. Now, get rid of the 3 by subtracting 3 from both sides. 3 take away 3 is 0. Negative 5 take away 3 is negative 8. Remember, this is another mistake right here. Right? A lot of people make a mistake on this. I don't know how many times I've seen that people put down this is equal to negative 2. And that is wrong. Right? Think about it being separate. This is a number, and this is a number. Negative 5 and negative 3. Here's my negative 5, and here's my negative 3. How many do you have altogether? Well, there's 5 and 3. That means 8, and they're all negatives. So don't do the 5 take away 3 here. All right. Cleaning it up, I now have 4x is equal to negative 8. So I'm multiplying by 4x, so we can now divide by 4. 4 divided by 4 is 1x. Negative 8 divided by 4 is 2, and it's negative. And of course, my answer is x equals negative 2. Okay, now that we've got that done, we're going to start talking about what are called the rational coefficients. Now, we've been using whole number coefficients and actually integer coefficients at this point. Now remember, the coefficient is the number in front of the variable. So this is, the coefficient here is 2, the coefficient here is negative 2, the coefficient here is 4. All right, so let's talk about what a rational number is, because that's what we're going to be starting with first. A rational number can be defined as a number that can be written in the form of a fraction m over n, where n cannot be a 0. Because if n's a 0, you get an undefined number. So both m and n have to be integers. So positive or negative numbers on top and bottom, where the bottom one cannot be a 0. That's how we define a rational number. Now, to simply put this, so you can understand it, it's positive and negative fractions and decimals. Okay? So to solve equations involving fractions, we have to review a few concepts first. I know that it's possible to use your fraction calculator to solve these problems. However, that causes issues later on when you've got to find the common denominator to get rid of your rational expressions. So you can use your calculator for fractions, and we'll go over that a little bit later. But for now, let's just talk about what you're going to need to know for next year in grade 10. So taking a look at this, I need to know what is the reciprocal for 3 over 4. Well, the reciprocal for 3 over 4 is actually 4 over 3. Now, why is it 4 over 3? Well, a reciprocal is defined as a fraction you use to get the product to equal 1. So I have to choose a number that's going to make this happen. Now, if I choose 4 over 3, 3 times 4 is 12, and 4 times 3 is 12. I end up with 12 over 12. Now, anything divided by itself is 1, or you can reduce this by dividing both top and bottom by 12, but we end up getting 1. So the reciprocal for 3 over 4 is 4 over 3. Okay, so if you have a fraction which contains a variable, we can use the concept of reciprocals to make this fraction turn into a whole number. So for example, remember, if I've got x over 4 and I want the 4 to go away, I can multiply by its reciprocal, by 4 over 1. Right? Now 4 times x and 4 times 1 gives me 4x over 4. 1 divided by 1 gives me 1x, and that leaves me with just an x. So if I multiply by the reciprocal, this fraction here disappears. So how do we apply that in an equation? Well, first you have to understand that fractions in equations cause difficulty. This is because most of them cannot be changed into the decimal equivalent accurately. Now, some of them, like this 3 over 4, when you divide it out, you get 0.75, and that's what we call an exact number. However, if you do 1 divided by 3, it becomes 0. And 3 goes on forever. Now, in order to use this number in a calculation, we've got to cut it off somewhere, right? And so if you cut it off here and just use 2 decimals, now I have 33 over 100. Now, when I try to reduce 33 over 100, I don't get 1/3. All right? It's 33 over 100. It's very close, but it's not 1/3. So by changing this into a decimal, I've actually introduced an error. So the 1/3 is actually more accurate than its decimal counterpart. Now up here, with what we call exact numbers, 4 divided by 3, so 3 divided by 4 gives you 0.75, and this one here actually becomes an exact number, so that one's okay. Right? This one here, it causes problems. So sometimes what we need to do is, rather than deal with the 1/3 and the 3/4 and exact and approximate and all that kind of stuff, we just get rid of them. Now, to do that, we're going to go look at what we did in grade 7, because this is one of the first times you actually encountered this. I've got x over 3 is equal to 4, and if my goal is to get rid of the 3, I've got to find the reciprocal of 1 over 3. Because remember, there's a 1x here, 1 over 3. Now, 1 over 3's reciprocal is 3 over 1. So what I do is I multiply both sides by 3 over 1. Now, we don't usually put the 1 under here, but it's still there, right? Now 3 times x is 3x, 3 times 1 is 3. 3 divided by 3 is 1, and that leaves me with x. Now on the right hand side over here, 4 times 3 is 12, that's all over 1. Anything divided by 1 is itself, so that becomes just simply 12. And here we're now down to x is equal to 12. So I multiplied by 1/3. If I multiply 1/3 by its reciprocal, 3 over 1, the fraction disappears. Now, we always do the multiplication of what's called the lowest common denominator. So if you have one fraction, 1/3, the lowest common denominator is 3. And if you have more of them, though, we have to do find the lowest common denominator, and you've done that before when we were adding fractions. So let's take a look at how this works in real life here. Okay, go into the next page. If I have x plus 1 over 7 is equal to 2, right? Now, you need to learn to do it this way. However, if I was on an achievement test and I had a fraction calculator, I'd be doing this. Shouldn't be there. X plus 1 over 7 minus 1 over 7 is equal to 2, take away 1 over 7. Now I caution you, this has to be done on a fraction calculator that stays in fraction, right? So 1/7 take away 1/7 gives me x plus 0, right? And 2 take away 1/7 gives, that's supposed to be equal. 2 take away 1/7 is 1 6/7, and your calculator would show you that. So what I end up getting is x is equal to 1 6/7. Now, if you're going to be using your calculator to do it, that's the easiest way to do it, and I recommend this. But for grade 10, you've got to be able to get rid of this 7 down here. And the reason for that is you're going to be encountering questions which have in the denominator, you've got binomials, x plus 2, right? And plus, I don't know, x plus 3. Equals, I'll just say 7. You've got to be able to find a way to get rid of the fractions. Say this is 6 and this is 9. You have to get rid of this, right? Now you can't get rid of this by using a fraction calculator. This won't work with a fraction calculator. What we need to do is to find the lowest common denominator. So this is what we're doing now. We're going to be working with how to do that. Now, what you need to do is take a look at every fraction here. This is actually x over 1, but that's the 1 on the bottom, doesn't matter. 2 over 1 doesn't matter. So my only common denominator here is actually a 7. So I have to multiply every single term. Important. Every single term. X has to be multiplied by 7. 1 over 7 has to be multiplied by 7. And this 2 has to be multiplied by 7. I don't know why I've got that there. That should be a 2. Okay? Now, when I do that, x times 7 is 7x, right? And x 1 over 7 times 7, mathematically it looks like this. There's a 1 there. 7 times 1 is 7, and 7 times 1 is 7. And of course, 2 times 7 is 14. So this becomes 1. So now I've got 7x plus 1 is equal to 14. Right? So now you look at it. I started with x plus a 7th equals 2. Now I don't have any fractions. Having gotten rid of the fractions, now we can solve it easily. Now I'm going to move on then to this one here. I need you to take a look at 3 and 2 and tell me what is the lowest common multiple. Now remember, multiples are the numbers that when you go 3, 6, 9, 12, and 2, 4, 6, 8, it's the first number that they actually become the same at. If you have a lot of time, a lot of difficulty, you can use multiplication, but be very, very careful with that. All right, so 3, 6, 9, 12, and it goes to a 6, right? How write those down, right? You got 3, 6, 9, and the 2 is 2, 4, 6. Now you notice that there's a 6 here and a 6 here. So my LCM, my lowest common multiple, is a 6. That means I have to multiply everything by 6. Okay. Now I want you to pause the recording. You now know this is 6. I want you to multiply each term by 6 and simplify it. So pause the recording and do that. Okay. So this is what it should look like to start out with. X over 3 times 6 minus 1/2 times 6 is equal to 4 times 6. Now this becomes 6x over 3. I'm going to do it the long way. 1 times 6 is 6, and that's all over 2, and 4 times 6 is 24. 6 divided by 3 is 2x, and 6 divided by 3 is 3. So I end up with 2x minus 3 is equal to 24. And then, of course, once that's done, then I can continue on down, and I can solve it. Right? But our goal right now is just to get rid of the fractions. Okay, taking a look at this one over here. Lowest common multiple. Well, I need you to try that. So I need you to give it a whirl. Now, you can multiply, but be very, very careful. You could use 72. 4 times 3 times 6 is 72. But that gets into some really big numbers. All right? It would be easier for you to try to figure out 4, 8, 12. Oh, wait a minute. 3 goes into 12 and 6 goes into 12. So that means that 12 is the lowest common multiple. So pause the recording and finish this off. Multiply all 3 terms by 12 and simplify it. Okay? Now, that gives me this. 3x over 4 times 12, 2 over 3 times 12, x over 6 times 12. The critical mistake that happens here, people don't multiply everything by 12. They skip something out. Okay, 3 times 12 is 36, so that's 36 over 4. 2 times 12 is 24 over 3. 12 times 1 is 12 over 6. 36 divided by 4 is 9. 24 divided by 3 is 8. 12 divided by 6 is 2. There you go. All of our fractions are now gone. Okay. Now sometimes the fractions have the variable in the denominator. In this case, the LCM. So taking a look at 4 over x equals 5. This causes an issue. Okay. Now my LCM is going to be an x because I've got a 1 over here. All right? So if I multiply everything by x, look what happens. I end up with 4 over x times x is equal to 5 times x. Now remember, this is over a 1 here, right? This is x over 1, and the multiply fractions is top times top and bottom times bottom. So we're talking about 4 times x over x, and 5 times x is simply 5x. So this is what I'm talking about. Now x over x is equal to 1, so these two x's cancel out and equal to 5x. So my question now becomes 4 is equal to 5x. Right? Now there is another way of doing this called cross multiplication, and some teachers will teach you how to do this, and this is what that looks like. You get 4 over x equals 5 over, and you have to put a 1 here. But cross multiplication says that you can multiply this way and that way and put them in the top. Right? So 4 times 1 is 4. 5 times x is 5x. Okay? But this works only if you've got two fractions equal to each other. All right? So be very, very careful if you want to try this method. The moment you have like, plus a 7 here, or sorry, 7x or whatever you want to try, then this whole method of cross multiplication doesn't work. So be careful with it. It's wiser for you to understand why it works by going through this here as it all disappears. Okay. I want you to try this one on your own, please. So stop the recording, and solve that equation by getting rid of the fraction. All right, first off, I've got an f in the denominator, and I've got a 1 over here under the 12. Remember, all numbers are over 1. So 4 over f, 12 over 1, lowest common multiple is f, multiply both sides by f. F over f cancels, leaving you with 4. Or you can say 1 and then multiply by 4. This becomes 12f, so our answer becomes 4 equals 12f. And now you can solve this without having to worry about a fraction. Okay, now we said fractions, now we also have decimals. Now where you have decimals, you've got to be even more careful, because dropping a decimal or putting it in the wrong spot, it just causes a lot of trouble. So now I've got 12x minus 3.5 is equal to 2.7. Now we cannot solve this question with tiles because you can't have tiles which are more than just an x or a whole number. So now we're down to how do you solve this using the steps we normally would. Now you want to get your variables by themselves, so the first thing we got to get rid of is the 3.5. Now remember we told you when you build an equation, it's bed mass, but when you're solving an equation, it's Sam Deb. Okay? Nah, writing with a mouse is a pain. But this is what's important here. Add and subtract first, then multiply and divide. It makes it so much easier. So I've got to get rid of the negative 3.5. To get rid of a subtracted 3.5, I've got to add a 3.5. Right? So I'm going to add 3.5 to both sides. Now you can use your calculator to do the math on the right hand side, but negative 3.5 and positive 3.5 give you 0. And of course 2.7 plus 3.5 gives you 6.2. The 0 goes away, leaving you with 1.2x is equal to 6.2. Now we're multiplying by 1.2, so to undo multiplying by 1.2, we're going to divide by 1.2. Anything divided by itself is 1. And of course 6.2 over 1.2 gives you 5.1, and then the 6 repeats. So we end up with x equals 5.1 with a 6 there. All right. Now you can do a fraction if you want to convert this into a fraction. Your fraction calculator will do that for you. But it's up to you. But it becomes 31 over 6. So anyway, rounding everything off to 2 decimal places, you get 5.16. Now when you have a question like this, you got to be very, very careful with your instructions. Look up in your instructions and find out what did it tell me to round to, or were there any instructions at all. When you're not told what to round to, we always assume we default to 2 decimal places, the nearest hundredth. Okay, so be aware of that. Okay, so now we're going to do the split variable one. I'm going to get you started on this one, but then you're going to finish it off. So I've got to get rid of sorry, I just yawned there. We got 3.5x minus 1.25 is equal to 5.35x plus 6.22. So we have to get rid of one of the x values on one of the sides. Now remember I told you, make sure that you keep everything positive. So I'm going to get rid of this here first. If I get rid of this, I'm going to add a 3.5x to this side. That'll become 0. And then I can add to this number here another 3.5x. This is what it's going to look like. Negative 3.5x plus 3.5x minus the 1.25. We haven't done anything with that, so it sticks around. Now, I added 3.5x on the left. That means I've got to add 3.5x on the right. That means I'm going to get this here added together, and I'm going to keep the 6.22. So when I simplify everything, I end up with this becoming a 0 minus 1.25. And of course, 5.35 and 3.5 gives me 8.85 plus the 6.2 with the x there. So cleaning it all up, don't drop the negative. Right? Cover the 0 for a second, you'll see that that's a negative 1.25. So don't lose it. Now, this is where I want you to pause the recording, and I want you to complete this equation, please. All right, so remember, got to get rid of the added or subtracted component when we're working to isolate the variable. That means I'm going to subtract 6.22 from both sides. So this becomes negative 1.25, subtract 6.22, and this becomes here a 0. So I now have 8.85x plus 0. Left-hand side, I've got negative 7.47. Remember, a negative and a negative, there's 2 separate numbers, just add them together, and that's how many negatives you have. Now, that simplifies out. Now I'm multiplying the variable by 8.85. So to undo that, I divide both sides by 8.85. Anything divided by itself is 1, so this becomes 1x. And over here I've now got negative, I don't know where the negative went, it should be there somewhere, negative 0.84406779666, and this ellipse means that it goes on forever. So now taking a look at that, we end up with negative 0.84. And I rounded it to 2 decimal places, so we have basically got our solution there. Now remember, if you round something, putting a dot over the equal sign is one way to show that you've rounded it, and the other way is use what's called a tilde, which looks like that. So both of these can replace that equal sign because this answer is not equal to 0.84. It's actually been rounded. So you want to tell somebody that, then you can put in the tilde there or the other one there, the dot over top of it. Okay. So now what we're going to do is we're going to use an equation to model and solve a problem. Now, to do this, this goes way back to grade 7, and it's very, very difficult because you can't get this wrong. If you get it wrong, there's no hope for you because you'll be solving the wrong equation. So you have to read extremely carefully. Now, the sum of three numbers says the sum. Now, the first thing you should notice is that the sum is the result of adding. The sum of three numbers, or 3 times a number, plus 5 is equal to 7 less than 7 times the number. So let's just start with the first. There's my equal sign. That's my beginning right there. So let's take a look at right here. Sum of 3 times a number. Well, 3 times a number is 3x, right? There's 3 times the number. The number is x. Plus 5. So my left-hand side looks like this. All right? And you can see right there, that's what it looks like right there. Now, having done that, I've got 3x plus 5. I guess I used an n here in my equation. Now, 7 less than 7 times a number. So I've got 7 times a number, but I need 7 less than that. So whatever this 7 times a number is, I've got to take away 7 from it. So it's going to look like 7n take away 7. Now, taking both of these and making them equal, now we can solve it. So what I'd like you to do is to pause the recording and solve this equation, please. All right, well, again, make sure everything stays positive. So in order to make sure that 7n here stays on the positive side, I'm going to take 3n from both sides. 3n take away 3n is 0. 7n take away 3n is 4n. And cleaning it up, I now have 5 is equal to 4n minus 7. Now, I need to get rid of the added or subtracted component first. So this negative 7 has to have a positive 7 put with it. But if I put a positive 7 on the right-hand side, I've got to put a positive 7 on the left. 5 plus 7 is 12. 7 take away 7 is 0. So cleaning that up, I now have 12 is equal to 4n. Now, I'm multiplying by 4, so I've got to divide by 4. 4 divided by 4 is 1. 12 divided by 4 is 3. So that leaves me with n is equal to 3. Now, if I want to do a verify on this, I've got 3n plus 5 is equal to 7n minus 7. Now, I said that n was 3, so it's going to be 3 times 3 plus 5 is equal to 7 times 3 minus 7. Now, remember, in order of operations, we multiply before we add, so 3 times 3 is 9. So on this side, I've got 9 plus 5. All right? 7 times 3 is 21. Take away 7. Well, 9 plus 5 is 14. 21 take away 7 is also 14. So we know that our equation, our solving, was done correctly. Now, remember what I told you about verifying. Do it honestly. Right? It doesn't do you any good to assume you did it correct because this is a way for you to check to find out if you did it wrong. Theoretically, if you can verify, you could solve any question in the world because you could just keep checking your answer. It might take you a while, but you could do it. How am I going to mark this? Formula, substitution, and of course, right down here, does it balance? If I was marking this one, you may or may not get a mark for the question, but I'd be doing what you did, what you got, what you did, what you got, what you did, what you got. So this question is looking at 1, 2, 3, 4, 5, 6, 7. And if you had to do a verify, you're looking at 10 marks. Okay. Oh, I did the verification on this side over here. So you can see, you can just copy this down. So pause the recording and copy that down there. Okay. So we know we correctly answered the question because 14 was equal to 14. So here's another problem. A cell phone company offers 2 plans. Plan A is 100 free minutes and then 0.85 per additional minute. Plan B is 40 free minutes and 0.30, which is 30 cents per additional minute. Which time for calls will result in the same for both plans? So where is the point where that actually balances? So if you only pay for a time here, let's get the left side done first, plan A. It is basically 100 minutes, right? That's the free ones, and you can take away 100 minutes from the time. So we've got time, take away the 100 minutes, and that equals 0.85. Now on the other side, you multiply, but you only get 40 free minutes, so this one looks like that. 0.30, and time take away 40 minutes. Setting them both equal to each other, this is what you get. Now, this here is probably about as difficult as the questions are going to get. You've got a split variables on both sides, but you also have a distribution law. So remember when we're doing a distribution law, if this is a 3 on to n plus 5, remember distribution law, everything inside has to be multiplied by the 3. All right, so this becomes 3n plus 3 times 5, so this becomes 3n plus 15. All right, so you're going to have to do the distribution law for both sides. So I'll get you started with it, but then I'm going to want you to finish it off. So 0.85 has to multiply by both the t and the negative 100. The 0.30 has to multiply both by the t and the negative 40, so this is what it looks like. Okay, I'm going to stop there, and I want you to pause the recording, and I want you to solve this equation. All right, so 0.85 times t just becomes 0.85t. This becomes 0.85 times negative 100, so this has become negative 85. This becomes 0.3t, and this becomes negative 12. 3 times 4 is 12. So this is what we end up with here after you do all your multiplication, and of course you can use your calculator to do it. Now, I've got the numbers here. I need to get the t's by itself. Remember, I want things to be positive. So since this is the largest t, I'm going to subtract 0.30t from both sides. Okay? I guess I started with the 85. Doesn't matter. We'll do it that way then. Okay, 85. Negative 85 and positive 85. If I add 85 here, I've got to add 85 there. So that means that this becomes 0. So I have 0.85t minus 0. And of course, negative 12 and 85 is 73. Cleaning it all up, now we have that. So now I can deal with the 0.3t. I'm going to subtract 0.3t from both sides. And that means this side or here, this is going to become 0 plus 73. And on the left-hand side, I have 0.85t minus 0.3t, which is 0.55t. Clean it up. That's what it looks like. We're multiplying by 0.55, so we're going to divide by 0.55. And whatever I do to the left, I've got to do to the right. This cancels, leaving me with 1t. On the right-hand side, I have 73 divided by 0.55, which is 132.72 minutes. Okay, so at that point, 132.72 minutes, these two plans will cost the same. All right. Time for your assignment. If you have any questions, take a look things over. Do it again, watch it again. Come and see me if you have any issues. And we'll see you in our next lesson.